Louis Pasteur, one of the most influential scientists in history, was born on December 27, 1822, in Dole, a small town in the Jura region of France. His family background played a significant role in shaping his character and ambitions. Pasteur was the third of 5 children born to Jean Pasteur, a tanner, and Jean Etienne, both of whom were devout Catholics. Despite the family's modest means, they placed a high value on education and intellectual pursuits. Pasteur's father, although a craftsman by trade, was an ardent believer in the importance of a good education, and this belief shaped the environment in which Pasteur grew up. Pasteur's early years were marked by a strong sense of curiosity, but he was initially not known as a prodigy. In fact, he struggled with schoolwork at the outset. In his early days at school, he was considered an average student, often failing to impress his teachers. However, Pasteur's persistence and dedication gradually emerged as he developed a particular interest in the sciences, particularly chemistry and mathematics. His time at the École Normale Supérieure, one of France's most prestigious academic institutions, would be a turning point in his academic career, marking the beginning of his transition from a local boy to a future scientific luminary. Pasteur's academic journey began in earnest in 1839 when he entered the Collège de Besançon. It was here that he first demonstrated the promise of his intellectual abilities, particularly in the areas of physics and chemistry. He was an excellent student, though still relatively shy and reserved. His ability to absorb knowledge quickly did not go unnoticed, and by 1843, he had earned a scholarship to study at the prestigious École Normale Supérieure in Paris. At this institution, Pasteur would refine his scientific thinking and lay the foundation for the revolutionary discoveries he would soon make. The École Normale Supérieure was a hotbed of intellectual activity, and Pasteur quickly became a part of its rigorous academic environment. Under the tutelage of eminent professors, he began to focus his attention on chemistry, particularly the nature of crystals. Pasteur's passion for this subject led to one of his first major breakthroughs, his discovery of the asymmetry of certain crystals. This work would eventually make him famous in the world of chemistry, although at the time, Pasteur was still only in his early 20s. One of the critical elements of Pasteur's early education was his immersion in the scientific method, which became central to his work throughout his career. During his time at the École Normale Supérieure, Pasteur was exposed to the works of leading scientists, and he began to experiment with the scientific principles that govern the natural world. His early focus on crystallography led to an understanding that would later inform his work in microbiology. Pasteur's methodical approach to experimentation and his attention to detail were traits that would define his future research. It was during these formative years in Paris that Pasteur also began to cultivate a reputation for persistence. He was known for his tireless work ethic and his ability to think deeply about scientific problems. While many of his peers were content with theoretical studies, Pasteur's inclination was toward experimentation. This characteristic would define his approach to science for the rest of his life. As a result, he quickly gained the respect of his professors and peers, and by 1847, he was appointed to a position as a professor of chemistry at the University of Strasbourg. In Strasbourg, Pasteur's career took another significant turn. His work began to extend beyond the realm of pure chemistry and into the burgeoning field of microbiology. It was here that he made the first of many connections between chemistry and biology. This period in Strasbourg proved to be one of deep intellectual growth for Pasteur, as he conducted pioneering experiments that bridged the gap between the physical and life sciences. His early research into fermentation, which would later lead to the development of his germ theory, was conducted during these years. Pasteur's move to Strasbourg also marked a new chapter in his personal life. He married Marie Laurent, the daughter of a wealthy Strasbourg merchant, in 1849. This union would be a source of personal strength for Pasteur, as his wife supported his scientific endeavors and stood by him through the challenges and obstacles that lay ahead. The couple would have 5 children, though tragically, only 2 of them survived to adulthood. Pasteur's personal life, marked by both joy and sorrow, was an important source of emotional resilience that helped him endure the difficult moments in his scientific career. As Pasteur's academic career progressed, so too did his commitment to advancing scientific knowledge. He began to shift his focus from pure chemistry to the practical applications of science, particularly in relation to public health and disease prevention. His work on fermentation and his investigation into the causes of microbial contamination would lay the groundwork for his later revolutionary work in immunology and microbiology. It was at this point in his life that Pasteur's reputation as a scientist began to grow beyond the academic world, as his research began to capture the attention of both the scientific community and the general public. Louis Pasteur's academic trajectory would not have been as remarkable had he not possessed an insatiable curiosity about the world around him. As a young man, Pasteur's early fascination with the natural world was a guiding force in his life. This curiosity first manifested during his time at the École Normale Supérieure, where he began to immerse himself in the study of chemistry and physics. But it was his encounter with the field of crystallography that would forever alter the course of his career. Crystallography, the study of the structure of crystals, was a field that was still in its infancy during Pasteur's years at the École Normale. The field had captivated the scientific community, and Pasteur, with his keen scientific instincts, was drawn to it as an opportunity to push the boundaries of knowledge. The study of crystals offered scientists a window into the molecular structure of materials, and Pasteur quickly recognized its potential to answer fundamental questions about the nature of matter itself. In 1845, Pasteur began his work on the asymmetry of crystals, a subject that would lead to one of his earliest major discoveries. He observed that certain crystals, particularly those associated with tartaric acid, were not symmetrical and could not be superimposed on their mirror images. This phenomenon, later termed optical activity, was not widely understood at the time, and Pasteur's insight was a breakthrough. He discovered that tartaric acid existed in 2 forms, a right-handed and a left-handed form, and that these forms had distinct properties. This was a revolutionary concept in chemistry, as it introduced the idea of molecular asymmetry, which would go on to play a crucial role in the development of modern chemistry and biochemistry. Pasteur's work on the optical activity of crystals would earn him widespread recognition in the scientific community. His meticulous attention to detail and his innovative approach to experimentation allowed him to make a contribution to the study of crystallography that had far-reaching implications. But more than just a scientific accomplishment, Pasteur's work in crystallography served as an introduction to the idea that small, often invisible forces could have a profound impact on the physical world. This realization would remain a guiding principle throughout his future research. Despite his growing reputation in chemistry, Pasteur was not satisfied with merely contributing to the body of knowledge in his field. His scientific curiosity was far-reaching, and he was driven by the belief that science should serve a practical purpose. This mindset would lead him to leave the realm of theoretical chemistry and venture into the burgeoning field of microbiology. At the time, the study of microorganisms was largely speculative, as scientists had not yet developed the tools or techniques to observe them in detail. However, Pasteur's instincts told him that the answers to some of the most pressing scientific questions lay hidden within a microscopic world. In the late 1840s, Pasteur's interest shifted toward fermentation, a process that had been a subject of scientific curiosity for centuries. The fermentation of wine, beer, and other substances have been studied by numerous chemists, but the underlying mechanisms remained unclear. Pasteur was particularly intrigued by the fact that different substances fermented in different ways, and he wondered whether microorganisms were responsible for these variations. His curiosity led him to explore this question with a level of intensity that would eventually redefine the scientific understanding of fermentation. Pasteur's pioneering experiments on fermentation began in 1857, and they would become some of the most influential studies in the history of microbiology. He found that the fermentation process was not a result of spontaneous chemical reactions, as had been believed, but rather the result of the activity of living microorganisms. This discovery would lead to the development of his germ theory, which posited that microorganisms were the cause of many diseases and that they could be controlled through careful manipulation of the environment. Pasteur's work in fermentation not only revolutionized the science of microbiology, but also had far-reaching implications for industries such as brewing, winemaking, and food preservation. One of Pasteur's most striking qualities was his ability to think beyond the confines of traditional scientific disciplines. His training in chemistry, which was grounded in the study of materials and their properties, had instilled in him a deep respect for empirical evidence. However, his move into the world of biology and microbiology required him to think in new ways. He began to understand that the microscopic world, though invisible to the naked eye, had a profound influence on the visible world. This realization would shape his future work and lead to discoveries that would change the course of medical science. As Pasteur delved deeper into the study of fermentation, he began to observe that different types of fermentation were caused by different microorganisms. He identified specific types of bacteria and yeast that were responsible for various types of fermentation, and he began to experiment with methods to control their activity. His work in fermentation ultimately led him to the concept of pasteurization, a process by which liquids such as milk and wine could be heated to a certain temperature to kill harmful microorganisms without altering the substance's flavor or quality. This method would go on to revolutionize the food industry and save countless lives by reducing the spread of foodborne illnesses. Pasteur's ability to apply scientific knowledge to practical problems was a hallmark of his work, and it was this skill that set him apart from many of his contemporaries. While other scientists were content to develop abstract theories or conduct experiments in isolation, Pasteur sought to apply his discoveries in ways that could benefit society. His work in fermentation and pasteurization provided concrete solutions to real-world problems and earned him the respect of both the scientific community and the general public. Moreover, Pasteur's scientific curiosity was not limited to his research alone. He was a tireless advocate for the advancement of scientific knowledge, and he believed deeply in the importance of collaboration among scientists. His work, though often groundbreaking, was built on the contributions of others. Pasteur's willingness to engage with the work of other scientists and integrate new ideas into his own research was a key factor in his success. His intellectual humility, coupled with his extraordinary drive to discover the truth, allowed him to make advancements that would have been impossible without the collaboration and exchange of ideas that were central to the scientific community of his time. The mid-19th century was a time of profound scientific transformation, particularly in the field of microbiology. While the idea that microorganisms played a role in fermentation was still in its infancy, Louis Pasteur's determination to understand this process would lead him to make one of the most significant contributions to science. Pasteur's interest in fermentation was not merely an academic curiosity, but a deeply practical pursuit that would change the way the world understood biology, chemistry, and disease. His studies on fermentation are not only among his earliest significant achievements, but also laid the foundation for his groundbreaking work in microbiology. At the time, the prevailing belief about fermentation was based on the theory of spontaneous generation, which held that life could arise spontaneously from non-living matter. This idea had been around for centuries and was widely accepted in both scientific and popular thought. However, Pasteur's scientific rigor and keen observation led him to question this belief, particularly in relation to the fermentation process. Fermentation, a biochemical reaction in which sugars are converted into alcohol or acid by microorganisms, was a common phenomenon in industries such as brewing, winemaking, and baking. Despite its practical importance, little was understood about its underlying causes. In 1857, Pasteur began conducting a series of experiments on fermentation in response to a request from the French industrialists who were seeking to improve the quality of wine. They had noticed that sometimes the fermentation process would fail, leading to spoiled wine. Pasteur, with his methodical approach to science, began investigating the chemical processes involved in fermentation, and his curiosity quickly led him to a startling conclusion. Fermentation was not the result of spontaneous chemical reactions, as many had thought, but was driven by the activity of living organisms. He observed that when microorganisms, particularly yeast and bacteria, were introduced to the fermentation environment, fermentation occurred, while in the absence of these microorganisms, the process would not take place. In 1859, Pasteur published his findings in a seminal work, Memoire sur la fermentation alcoolique, Memoir on alcoholic fermentation. This paper described his experimental work, in which he demonstrated that microorganisms were responsible for fermentation. Pasteur's experiments with yeast, particularly his ability to distinguish between different types of yeast and their effects on fermentation, offered definitive proof that fermentation was a biological process, not a chemical one. His discovery was groundbreaking because it refuted the theory of spontaneous generation and demonstrated that life was necessary for fermentation to occur. One of Pasteur's key experiments involved the use of specially designed flasks that were sealed with a long, curved neck, what we now know as the swan neck flask. In these flasks, Pasteur introduced a nutrient-rich liquid and then exposed it to the air. In one set of flasks, he allowed the air to flow freely into the liquid, while in another set, he used the swan neck design to prevent air from coming into contact with the liquid. Over time, Pasteur observed that in the flasks exposed to air, microbial growth occurred, while the sealed flasks remained free of microorganisms. This experiment provided strong evidence that microorganisms in the air were responsible for fermentation and that life did not spontaneously arise from non-living matter. The swan neck flask experiment would become a critical demonstration of Pasteur's rejection of spontaneous generation and his support for the germ theory of disease. Pasteur's fermentation studies not only revolutionized the understanding of this biological process, but also had profound implications for the broader scientific community. His experiments on fermentation were among the first to suggest that microscopic organisms, such as bacteria and yeast, could cause biological processes. His meticulous experimental design and the clarity with which he communicated his findings established him as one of the foremost scientists of his time. The implications of his work extended far beyond fermentation. Pasteur's findings laid the groundwork for the development of germ theory, which would go on to reshape the fields of medicine, hygiene, and public health. Through his fermentation research, Pasteur also made critical discoveries regarding the role of bacteria in spoilage and disease. In particular, he began to explore the ways in which bacteria could contaminate food and drink, causing them to spoil or ferment in undesirable ways. His studies of the wine industry were particularly influential in this regard, as he demonstrated that spoilage in wine was the result of the action of harmful bacteria. Pasteur's insight into the microbial origins of spoilage led him to the development of pasteurization, a method of heating liquids to a specific temperature to kill harmful bacteria without affecting the quality of the product. The application of Pasteur's theory of fermentation to the food and beverage industry would be transformative. His work in this area not only improved the quality of wine and beer, but also had significant implications for public health. Pasteur's understanding of fermentation was integral to the development of a range of food preservation techniques, and it laid the foundation for modern microbiology and food safety standards. His work on fermentation and spoilage, along with the broader application of his discoveries, would eventually lead to improved sanitation practices in hospitals, the introduction of vaccines, and the widespread understanding that microscopic organisms could be both beneficial and harmful to humans. Despite his growing fame in the scientific community, Pasteur's work on fermentation and microorganisms was still met with some resistance. Many scientists continued to adhere to the belief in spontaneous generation, and Pasteur's conclusions about the role of microorganisms in fermentation were controversial at first. However, his relentless pursuit of evidence and his rigorous experimental methods eventually won over skeptics, and his work on fermentation became widely accepted. Pasteur's discoveries in this area did more than just change the scientific understanding of fermentation. They helped establish him as a leading figure in the burgeoning field of microbiology. The revolutionary nature of Pasteur's work in fermentation went beyond the immediate impact it had on industry and public health. It marked the beginning of a broader scientific movement that would ultimately lead to the acceptance of the germ theory of disease. Pasteur's work on fermentation was one of the first clear demonstrations that microorganisms were not only responsible for certain biochemical processes, but could also be agents of disease. This realization would pave the way for Pasteur's later research on vaccination and sterilization, which would further cement his legacy as a pioneer in the study of microorganisms and their relationship to human health. By the early 1860s, Louis Pasteur had already demonstrated that microorganisms played a pivotal role in processes like fermentation, but his scientific journey was far from complete. His research in fermentation had brought him face to face with a new and perplexing question. Could microorganisms be the cause of diseases as well? This question would eventually lead Pasteur to one of his most groundbreaking contributions to science: the development of the germ theory of disease. Before Pasteur's work, the prevailing belief in medicine and biology was the theory of miasma, which posited that diseases like cholera, malaria, and the plague were caused by bad air or noxious vapors emanating from decaying organic matter. This theory had been widely accepted for centuries, largely due to the observation that disease outbreaks often seemed to coincide with filth and unsanitary conditions. However, there was no clear understanding of the microscopic mechanisms that could cause these ailments. This gap in knowledge provided the fertile ground for Pasteur's pioneering work on the role of microorganisms in human health. Pasteur's journey into the realm of disease began in the early 1860s when he was called upon to investigate a series of troubling outbreaks in the silk industry. A disease was spreading among the silkworms that were essential to the industry, threatening the livelihoods of countless farmers. The cause of the disease was unknown, but the outbreaks were devastating. Pasteur's first step was to observe the affected silkworms and their environments under a microscope. He quickly realized that the disease was not due to bad air, but rather to the presence of specific microorganisms that infected the silkworms. This realization marked the first steps toward what would become his germ theory. In 1865, Pasteur published his findings on the silkworm disease, showing that it was caused by a microscopic organism, which he later identified as a specific type of protozoan. This discovery was groundbreaking because it showed, for the first time, that a disease in animals was caused by a microorganism, not by environmental factors. Pasteur's work on silkworm diseases was a significant turning point, as it introduced the idea that microorganisms could be responsible for illnesses in both animals and humans. However, it was still a long leap to apply this concept to human diseases, and Pasteur's work would go on to provoke heated debates within the scientific community. At this time, the medical establishment was highly skeptical of Pasteur's hypothesis. Despite his successful work with silkworms, many in the medical field still clung to the miasma theory, which lacked the concrete evidence that Pasteur's research was providing. Nevertheless, Pasteur was not dissuaded by the criticism. His rigorous approach to scientific experimentation, combined with his intuition and deep curiosity, drove him to further investigate the relationship between microorganisms and human disease. He expanded his focus to broader questions, including the transmission of diseases in humans. In 1867, Pasteur made another key leap in his research when he was asked to investigate the problem of puerperal fever, a deadly condition that affected many women after childbirth. Doctors were baffled by the high mortality rate associated with childbirth, but Pasteur, drawing on his recent work with silkworms, suggested that the disease might be caused by microorganisms that were transferred from one patient to another through contaminated hands, instruments, or bedding. Pasteur's assertion that microorganisms could be transmitted through such means was a revolutionary idea at the time, but it was largely ignored or dismissed by the medical community, which was still entrenched in the miasma theory. The breakthrough came in 1867 when Joseph Lister, a British surgeon who had been reading Pasteur's work, applied the idea of germs to surgical practices. Lister, inspired by Pasteur's observations about microorganisms, began to use antiseptics to sterilize wounds and surgical instruments. His use of carbolic acid dramatically reduced the incidence of post-surgical infections and demonstrated that microorganisms were indeed involved in causing infections. Lister's application of Pasteur's germ theory in surgery marked the beginning of modern antiseptic techniques and showed the world the practical, life-saving implications of Pasteur's discoveries. As Pasteur continued to refine his theories about disease, he began to focus on human pathogens and their role in causing specific diseases. In the 1870s, he turned his attention to one of the most deadly diseases of the time, rabies. The disease was widely feared for its high mortality rate and its terrifying symptoms. Pasteur was determined to understand how the disease was transmitted and whether it could be prevented. He suspected that rabies, like other diseases, might be caused by microorganisms, and his investigation would lead to another of his great discoveries. In 1885, after years of research, Pasteur developed the first vaccine for rabies. The process involved inoculating a dog with the weakened form of the virus, and then administering the vaccine to a human patient who had been bitten by a rabid animal. The first human recipient of the vaccine was a young boy named Joseph Meister, who had been bitten by a rabid dog. Pasteur's vaccine saved Meister's life, and the success of the treatment was a turning point in the acceptance of the germ theory of disease. Pasteur's work on rabies not only proved the theory that microorganisms could cause diseases, but also demonstrated that such diseases could be prevented through vaccination. Throughout this period, Pasteur's work continued to gain momentum. He demonstrated that different diseases were caused by different microorganisms, and he developed techniques to isolate and identify the specific agents responsible for these diseases. Pasteur's development of vaccines, including those for anthrax and rabies, established him as a leading figure in medical science. His germ theory provided a scientific framework for understanding disease transmission, infection, and prevention. The practical applications of his discoveries, such as vaccination, began to save lives on a large scale. The germ theory of disease marked the beginning of a new era in medicine. Pasteur's work led to the development of aseptic surgical techniques, the creation of vaccines, and a deeper understanding of the ways in which diseases are transmitted and prevented. It also laid the groundwork for the development of antibiotics, which would further transform the treatment of infectious diseases in the 20th century. Pasteur's contributions to the germ theory not only revolutionized medicine, but also had a profound impact on public health, sanitation, and hygiene. By the late 19th century, Louis Pasteur had established himself as one of the leading figures in the scientific community. His pioneering work in microbiology, particularly his development of the germ theory of disease, had revolutionized medical science. However, Pasteur's scientific curiosity was far from satisfied. His studies on fermentation and disease had sparked a new question in his mind. Could diseases caused by microorganisms be prevented or cured through the introduction of weakened or attenuated versions of those microorganisms? This question would lead to one of his most significant achievements, the development of vaccines. The notion of using weakened or inactivated forms of pathogens to prevent disease was not entirely new. In ancient China, for example, smallpox inoculation, an early form of vaccination, was practiced by deliberately exposing individuals to material from smallpox sores in hopes of inducing a mild form of the disease that would confer immunity. Similarly, Edward Jenner's smallpox vaccine, developed in 1796, had shown that inoculation with cowpox could protect against smallpox. However, these early methods were rudimentary and lacked the scientific understanding that Pasteur would bring to the field. Pasteur's approach would be grounded in his rigorous experimental methodology and his understanding of microorganisms. Pasteur's first major breakthrough in vaccine development occurred in the 1870s, when he began working with the bacterium Bacillus anthracis, the causative agent of anthrax. Anthrax was a significant threat to both animals and humans, particularly in agricultural regions. Livestock deaths from anthrax were frequent, and its fatality rate in humans was high. Pasteur's investigation into anthrax was motivated by a desire to prevent these deaths, and he saw the potential for vaccination as a means of controlling the disease. In 1881, after years of research, Pasteur demonstrated that a weakened strain of Bacillus anthracis could be used to inoculate animals against the disease. He conducted a public demonstration in front of an audience of French scientists and government officials. In his experiment, Pasteur administered a weakened form of the anthrax bacterium to a group of sheep, while another group received no vaccination. The vaccinated sheep survived exposure to the deadly anthrax strain, while the unvaccinated animals died. This dramatic demonstration of vaccination's effectiveness solidified Pasteur's reputation and marked the first successful use of a vaccine for a bacterial disease. Following this success, Pasteur turned his attention to another deadly disease, rabies. Rabies was a particularly terrifying illness because it was nearly always fatal once symptoms appeared. It was transmitted through the saliva of infected animals, often through bites, and was a significant public health concern. The development of a vaccine for rabies became one of Pasteur's most ambitious goals. He began by studying the virus in detail, looking for ways to weaken or attenuate it so that it could be used safely as a vaccine. The road to the rabies vaccine was long and challenging. Pasteur's approach involved a series of careful experiments on the rabies virus. He initially inoculated rabbits with the virus and allowed them to develop mild symptoms. Then he would dry the spinal cords of these infected rabbits and use the dried material as a vaccine. Through repeated trials, Pasteur managed to attenuate the rabies virus to the point where it could stimulate immunity in animals without causing them to develop the full disease. In 1885, Pasteur was presented with an opportunity to test his rabies vaccine on a human subject. A young boy named Joseph Meister had been bitten multiple times by a rabid dog, and his chances of survival were slim. Pasteur, convinced that his vaccine could prevent the onset of the disease, administered it to the boy over a series of days. The treatment was a success. Joseph Meister survived without developing rabies, marking the first successful use of the rabies vaccine in a human. This dramatic success captured the imagination of the public and solidified Pasteur's status as one of the foremost scientists of his time. Pasteur's work on a rabies vaccine was a watershed moment in the history of medicine. It not only saved lives, but also provided a proof of concept for the use of vaccines in preventing infectious diseases. Pasteur's method of attenuating pathogens to create a vaccine would become the standard for future vaccine development. His success with rabies inspired further research into other infectious diseases and led to the development of vaccines for a variety of bacterial and viral diseases, setting the stage for the global vaccination programs that would follow. Following his success with rabies, Pasteur focused on developing vaccines for other diseases. One of his next targets was chicken cholera, a disease that affected poultry and was responsible for significant economic losses in the poultry industry. Pasteur's approach to the cholera vaccine was similar to his work with rabies. He aimed to weaken the pathogen and introduce it in a way that would stimulate an immune response without causing the full disease. By 1880, he had developed a weakened strain of the bacterium that could be used as a vaccine. Pasteur's success with chicken cholera was yet another demonstration of the potential for vaccines to control infectious diseases, and it cemented his reputation as the father of immunology. Throughout his vaccine research, Pasteur faced numerous challenges, both scientific and personal. The development of vaccines required meticulous experimentation, careful observation, and the constant refinement of techniques. Pasteur's unwavering dedication to the cause of vaccine development, combined with his scientific acumen, allowed him to overcome these challenges and achieve remarkable successes. However, Pasteur's work on vaccines was not limited to laboratory research. He was deeply committed to making vaccines accessible to the public and to promoting their widespread use as a means of preventing disease. Pasteur's work on vaccines also had profound societal implications. The development of effective vaccines led to the establishment of public health campaigns and vaccination programs that would save millions of lives over the course of the 20th century. Vaccination became a cornerstone of public health, and Pasteur's methods laid the foundation for the global eradication efforts that would later target diseases such as smallpox and polio. His work on vaccination not only transformed the field of medicine, but also contributed to the growing understanding that prevention, rather than treatment, was the most effective way to combat infectious diseases. As Louis Pasteur's scientific career progressed, his discoveries began to have profound and practical applications in everyday life. One of his most influential contributions, which has impacted industries worldwide, is the process known as pasteurization. Initially developed to improve the quality of beverages like wine and beer, pasteurization would later become a foundational method in food safety, ensuring that products such as milk and juice could be consumed with much less risk of contamination. This achievement not only highlighted Pasteur's ability to address real-world problems, but also demonstrated the lasting impact of his discoveries on public health and industry. Pasteur's interest in pasteurization began in the early 1860s, following his work on fermentation. The French wine industry, in particular, had been struggling with frequent spoilage of wine, often caused by the growth of unwanted bacteria and yeast during fermentation. While studying the fermentation process, Pasteur realized that certain bacteria and yeast were responsible for spoilage, leading to undesirable changes in taste, appearance, and overall quality. This discovery prompted him to consider how he could prevent the growth of these microorganisms without affecting the quality of the product. In collaboration with French winemakers, Pasteur began experimenting with heating wine to a specific temperature that would kill harmful microbes while leaving the wine's flavor intact. In 1865, Pasteur conducted a series of experiments that tested the effects of heat on both wine and beer. He discovered that heating the beverages to a moderate temperature, just below boiling, would kill the spoilage-causing microbes without altering the taste of the beverage. This was a revolutionary breakthrough, as it provided an effective method of preserving the quality and safety of wine, beer, and other fermented products. Pasteur's findings were published in 1867, and soon the process of heating wine and beer became widely adopted as a way to improve the stability and shelf life of these products. While pasteurization initially focused on the wine and beer industries, its applications quickly expanded to other areas. In particular, Pasteur's work began to influence the dairy industry. Milk, being a highly perishable product, was frequently contaminated with harmful bacteria, leading to foodborne illnesses that could be devastating to public health. Pasteur recognized the importance of extending the shelf life of milk and other dairy products. And in the late 19th century, he began experimenting with the pasteurization of milk. The key innovation in pasteurizing milk was the development of a method that involved heating the liquid to a specific temperature for a short period of time. This process killed harmful bacteria, such as Mycobacterium tuberculosis, which causes tuberculosis, and Brucella abortus, which causes brucellosis, without compromising the taste or nutritional value of the milk. Pasteur's research on milk pasteurization made it possible for consumers to enjoy dairy products with much less risk of bacterial contamination, significantly reducing the incidence of milk-borne diseases. Although Pasteur's work on pasteurization was transformative, it was not without its challenges. The initial opposition from some sectors of the dairy and food industries came from concerns about the practicality and cost of implementing the new technique on a large scale. However, over time, the benefits of pasteurization became undeniable, and its widespread adoption ultimately led to a marked decrease in the transmission of foodborne illnesses. Pasteur's method was so effective that it is still in use today in the modern dairy industry, as well as in the processing of fruit juices, canned foods, and other perishable products. The impact of pasteurization extended far beyond the immediate effects it had on food safety. It played a crucial role in the broader movement towards sanitation and hygiene in public health. Pasteur's work in food preservation and his recognition of the dangers posed by microorganisms in everyday life contributed to a wider understanding of how cleanliness, sanitation, and the control of bacterial growth could prevent disease. Pasteur's research helped usher in an era of public health reforms that would improve living conditions and protect people from harmful pathogens in their food and environment. Pasteurization also had a lasting influence on the broader field of microbiology. By demonstrating that microorganisms could be destroyed through heat, Pasteur provided one of the first practical applications of germ theory in everyday life. His work paved the way for other methods of sterilization and disinfection, such as the development of autoclaving techniques used in hospitals to sterilize surgical instruments. In this way, Pasteur's contributions to food safety were part of a larger scientific effort to control microbial contamination and prevent infectious diseases. In addition to its scientific and public health implications, pasteurization also had significant economic consequences. By extending the shelf life of food products and reducing spoilage, pasteurization made it possible to transport dairy products and other perishable goods over greater distances, facilitating the growth of national and international trade. It also helped stabilize prices and improve the availability of food in markets, as the risk of spoilage was reduced. As such, Pasteur's invention had far-reaching consequences not only for health, but also for global commerce and industry. Pasteurization's legacy can also be seen in its role in shaping modern food safety standards. Today, the process is a critical part of food regulation and safety guidelines around the world. Governments, including those in the United States, the European Union, and many other countries, have implemented mandatory pasteurization standards for a wide range of products, including milk, juices, and eggs. These regulations have been instrumental in reducing the prevalence of foodborne illnesses and ensuring that consumers have access to safe, high-quality food products. Moreover, the concept of pasteurization has been adapted and expanded upon in many areas of science and industry. For example, in the pharmaceutical industry, pasteurization methods are employed to sterilize vaccines and other medical products. In the beverage industry, pasteurization has been adapted to preserve a wide variety of drinks, from fruit juices to energy drinks. The process is also used in the production of certain canned foods, where the goal is to extend shelf life and ensure the safety of the product. Pasteur's discovery of the benefits of controlled heat treatment has left an indelible mark on countless industries, and its influence continues to grow as technology advances. As Louis Pasteur's groundbreaking discoveries reshaped the world of science and medicine, his contributions laid the groundwork for many of the most significant advancements in microbiology and modern healthcare. While his work on fermentation, vaccination, and pasteurization had immediate practical applications, his lasting influence extended far beyond his own era. Pasteur's research fundamentally transformed the way scientists understood disease, the mechanisms of infection, and the role of microorganisms in human health. His legacy is seen not only in the fields of immunology and public health, but also in the very foundation of modern microbiology and the clinical practices that continue to shape the treatment and prevention of diseases today. The germ theory of disease, which Pasteur helped pioneer, revolutionized medicine. Before Pasteur, medical science lacked a coherent understanding of how diseases were transmitted. The prevailing miasma theory, which suggested that diseases were caused by foul air or bad vapors, was the dominant explanation. Pasteur's observations and experiments proved that microorganisms, not atmospheric conditions, were the true agents of disease. This realization shifted medical thinking away from generalized and imprecise ideas to a more precise and scientifically grounded understanding of infectious diseases. One of the most enduring aspects of Pasteur's legacy is his role in the establishment of microbiology as a formal scientific discipline. Pasteur's meticulous studies and experimental methods paved the way for the development of microbiology laboratories and research institutions around the world. He demonstrated that microorganisms were responsible for a wide range of diseases, from foodborne infections to deadly epidemics, and that these organisms could be isolated, studied, and controlled. As a result, scientists could now focus on identifying specific pathogens, understanding how they cause disease, and developing ways to combat them. In the years following Pasteur's death, the field of microbiology advanced rapidly. Scientists built on his discoveries, identifying new pathogens and uncovering the underlying biology of infectious diseases. The ability to cultivate and isolate microorganisms in laboratories allowed researchers to explore the intricacies of bacterial, viral, and fungal infections. Pasteur's work laid the foundation for the development of diagnostic tools that could identify pathogens with greater precision, allowing for earlier detection and more targeted treatments. Pasteur's methods of sterilization, hygiene, and vaccination became central to modern medical practices. In hospitals, the recognition that infections could be prevented through sanitation and sterile techniques saved countless lives. Surgeons adopted Pasteur's principles, recognizing the importance of cleanliness in preventing postoperative infections. Hospital protocols evolved to emphasize the sterilization of instruments and the use of antiseptics, which drastically reduced the risk of surgical infections. Today, the practice of aseptic technique is a cornerstone of medical care, reducing the spread of infections and ensuring the safety of patients undergoing surgery. Perhaps one of Pasteur's most significant contributions to modern medicine is his pioneering work in the development of vaccines. His success with the rabies vaccine, which he introduced in 1885, was a major milestone in immunology and clinical medicine. The principles he established for vaccine development, using attenuated or killed pathogens to stimulate immunity, formed the basis for the creation of many vaccines in the years to come. The success of the rabies vaccine also marked the beginning of large-scale vaccination efforts, which have since led to the near eradication of several deadly diseases, including smallpox and polio. Vaccination, as it was championed by Pasteur, became an essential tool in public health worldwide. Governments and healthcare organizations implemented vaccination programs to control the spread of infectious diseases, leading to dramatic reductions in mortality rates. For example, the development of the DTP vaccine against diphtheria, tetanus, and pertussis in the 20th century was influenced by Pasteur's techniques. Vaccines for diseases like measles, mumps, rubella, and influenza have saved millions of lives globally, demonstrating how Pasteur's methods and immunization continue to have a profound impact. In addition to his work in vaccines, Pasteur's legacy in microbiology extended to the development of antibiotics. Although antibiotics would not be discovered until after Pasteur's death, his groundbreaking work in microbiology set the stage for the discovery of penicillin in 1928 by Alexander Fleming. Pasteur's recognition that microorganisms could be targeted by specific treatments provided the scientific foundation for the development of antibacterial agents. In this sense, Pasteur's influence indirectly helped to shape the era of antibiotic medicine, which revolutionized the treatment of bacterial infections. In the 20th and 21st centuries, Pasteur's contributions continue to influence public health policies. The fight against emerging infectious diseases, such as HIV/AIDS, Ebola, and COVID-19, has drawn on the principles established by Pasteur's pioneering work in microbiology. Scientists and healthcare professionals continue to study and respond to new pathogens using the tools and frameworks that Pasteur helped develop. The ability to trace the origins of diseases, understand how they spread, and develop targeted vaccines and treatments owes much to Pasteur's vision of scientific inquiry and his contributions to the understanding of the microbial world. Pasteur's work also had a profound impact on the development of biotechnology, a field that now plays a vital role in modern medicine, agriculture, and environmental science. The techniques Pasteur introduced for manipulating microorganisms, such as fermenting yeast or isolating bacteria for further study, are now integral to biotechnological applications. Biotech companies around the world use the principles of microbiology to engineer microbes for producing medicines, biofuels, and even food products. The process of genetic modification, which involves altering the DNA of organisms to produce desired traits, could be traced back to the foundational work that Pasteur began in understanding how microorganisms could be controlled and utilized for human benefit. In addition to his work in science and medicine, Pasteur's impact on education and scientific methodology is worth noting. His insistence on careful experimentation, observation, and the application of the scientific method has influenced generations of researchers and scientists. Pasteur's emphasis on empirical evidence and controlled trials set a standard for future scientific inquiry and taught the world that knowledge is best gained through careful observation and rigorous testing. His approach to research and experimentation has been embraced in countless fields, from microbiology and immunology to genetics and epidemiology. Pasteur's influence also extends to the way society perceives science itself. His successes demonstrated the power of scientific knowledge to improve human life, making science a tool not just for theoretical exploration, but for solving practical, pressing problems. His ability to link scientific research to tangible benefits for society helped to elevate the status of science in the public eye, fostering a greater appreciation for the importance of scientific innovation and discovery. Louis Pasteur's life was marked not only by his immense scientific achievements, but also by significant personal struggles and challenges that he faced both in his career and in his private life. While his groundbreaking discoveries and innovations are well known, they did not come without a personal cost. Pasteur's determination and dedication to science were matched only by his deep emotional and physical burdens. He was driven by a desire to serve humanity, but this drive also led him to endure a series of trials that would shape his character, deepen his resolve, and define his legacy in a way that extended beyond the laboratory. Pasteur's journey into science began with a sense of personal doubt. Born into a family of tanners in Dole, France, Pasteur was not initially considered a natural scholar. He struggled with his early education, and many of his teachers were unimpressed with his academic abilities. However, Pasteur's persistence and curiosity about the world around him propelled him forward, eventually leading him to the prestigious École Normale Supérieure in Paris. While he would go on to become one of the most celebrated scientists in history, his early years were marked by a sense of uncertainty about his place in the academic world. This early sense of self-doubt, however, was something that he continually overcame throughout his life. Another significant challenge that Pasteur faced was his own health. In 1868, when Pasteur was just 46 years old, he suffered a debilitating stroke that left him partially paralyzed on one side of his body. This sudden health crisis was a devastating blow, both personally and professionally. For a time, it seemed as though his career might be over, as he was unable to perform basic tasks and was confined to a wheelchair. Despite this, Pasteur's resilience and determination shone through. With the help of his wife, Marie, and his assistants, Pasteur slowly regained his strength and was able to resume his scientific work. This period of recovery marked a turning point in Pasteur's life, as it fueled his sense of purpose and determination to continue his research, even in the face of overwhelming adversity. Marie Pasteur, who was not only his wife, but also his closest confidant and intellectual partner, played a pivotal role in helping him through this difficult period. Their relationship was built on a strong foundation of mutual respect and shared intellectual curiosity. Marie, whom Pasteur married in 1849, was a significant emotional support during his moments of personal hardship. She assisted in his scientific work and was instrumental in managing his affairs when his health faltered. Their partnership was one of profound collaboration and mutual devotion, and it was through Marie's steadfast support that Pasteur was able to overcome the challenges of his illness and continue to make groundbreaking discoveries. In addition to the stroke, Pasteur's later years were also marked by intense periods of personal grief. In 1880, Pasteur lost one of his children, his beloved daughter, Camille, to a sudden illness. Camille's death was a crushing blow to the Pasteur family, and it affected Pasteur deeply. It is said that he never fully recovered from the emotional toll of losing his daughter, and it cast a shadow over the remainder of his life. Camille had been a bright, promising young woman, and her death was a personal tragedy for Pasteur. His grief, however, did not deter him from his work. Rather, it seemed to deepen his sense of commitment to the scientific pursuit of knowledge and the betterment of humanity. Despite these personal losses, Pasteur's work continued to be his primary focus. He was known for his tireless dedication to his research, often working long hours in his laboratory. However, his personal life was not without its moments of joy and fulfillment. Pasteur's love for his family, his connection to his colleagues, and his passion for science provided him with an emotional anchor throughout his life. He was a man of strong convictions, driven by the belief that his work could contribute to the betterment of human society. Pasteur's character was defined not only by his intellectual brilliance, but also by his deep moral compass. He viewed science as a tool for improving the human condition, and he felt a personal responsibility to use his discoveries to help others. His sense of duty to humanity was so profound that he was often willing to sacrifice personal comforts and time with his family to pursue his scientific endeavors. His work on the rabies vaccine, for example, was not simply a scientific challenge, but a personal mission to save lives. The success of the rabies vaccine, which saved the life of a young boy in 1885, was a testament to Pasteur's deep empathy for others and his unyielding commitment to making a difference in the world. Pasteur's humility was also a notable aspect of his character. Despite his immense success and international recognition, he was not one to seek fame or glory. He believed that the true reward of scientific discovery lay not in personal accolades, but in the knowledge that one's work had the power to help others. In fact, Pasteur was known to be somewhat reserved and private, and he did not actively court public attention. His focus was always on the pursuit of knowledge and its practical application to solve real-world problems, rather than seeking the limelight for his own achievements. Though Pasteur's professional life was marked by a series of triumphs, it was his personal journey that made him a figure of immense respect and admiration. His ability to persevere through illness, personal loss, and professional challenges exemplified the resilience of his character. Pasteur's deep sense of responsibility to his work, his family, and society drove him to become a man who would change the course of history. His dedication to science was not just a career, but a calling, and he approached his life's work with a level of seriousness and commitment that inspired those around him. By the time of his death in 1895, Louis Pasteur had not only transformed the fields of microbiology, immunology, and medicine, but had also left an indelible mark on the world through his character and personal integrity. His life was one of great personal and professional sacrifice, but it was also a life of immense accomplishment and contribution to the well-being of humanity. Pasteur's ability to overcome adversity, both personal and professional, made him a figure of enduring inspiration. His story is one of perseverance in the face of hardship, a reminder that even in the darkest of times, the pursuit of knowledge and the drive to make the world a better place can lead to transformative change. In the twilight of his career, Louis Pasteur directed his energy toward a vision that would extend his scientific mission far beyond his own lifetime: the founding of a research institution dedicated to the study of infectious diseases and the training of future scientists. This vision materialized in 1887 with the creation of the Institut Pasteur in Paris, an institution that would go on to become a global leader in biomedical research. Far from being a mere personal monument, the Institute represented a culmination of Pasteur's lifelong commitment to science in service of humanity, a place where research, medicine, and education would converge under the banner of public health. The impetus for founding the Institute emerged from the overwhelming success of Pasteur's work with the rabies vaccine. The public, moved by the life-saving potential of his discovery, rallied behind the idea of supporting a dedicated center for scientific research. Contributions flowed in from around the world. Kings, heads of state, private citizens, and institutions alike donated to the cause. The international nature of the support reflected the widespread admiration Pasteur had earned, as well as the universal relevance of his scientific achievements. The construction of the Institut Pasteur thus became a collective endeavor, a symbol of global solidarity in the fight against disease. Located on Rue du Tat in Paris, the Institute officially opened its doors in 1888, just a year after its foundation. Architecturally modest, but functionally ambitious, the building housed laboratories, lecture rooms, and treatment areas for patients. Pasteur was deeply involved in its design and organization, ensuring that it would meet the practical needs of researchers while fostering an environment of rigorous scientific inquiry. His vision extended beyond French borders. He intended the Institute to serve as a model for other countries and hoped it would foster international collaboration among scientists working on the frontiers of disease control. One of the Institute's earliest mandates was the continued production and distribution of the rabies vaccine. It also served as a treatment center where patients bitten by rabid animals could receive life-saving care. This function gave the Institute a dual role, as both a research facility and a medical clinic. The approach was groundbreaking at the time, as it combined research with immediate application. It reflected Pasteur's belief that science should never be isolated from practical outcomes, and that knowledge gained in the laboratory should swiftly be put to work in the service of society. The scientific staff at the Institute were handpicked by Pasteur himself, many of them drawn from the ranks of his former students and protégés. Among them were future luminaries of science, including Émile Roux, Albert Calmet, and Alexander Yersin. Under Pasteur's mentorship, they would go on to make discoveries that paralleled his own insignificance, such as Calmet's development of the BCG vaccine for tuberculosis and Yersin's identification of the plague bacillus. Pasteur's leadership style emphasized discipline, collaboration, and a relentless pursuit of truth, creating a fertile ground for scientific excellence. From its inception, the Institut Pasteur was envisioned as an international hub. In the years following its establishment, branch institutes were founded across the globe, in Saigon, Algiers, Tunis, and later in Dakar and other parts of the world. These satellite institutions brought the fight against infectious diseases to local populations, often in regions where outbreaks were common and healthcare infrastructure was minimal. Pasteur's idea had become a movement, and his name became synonymous with humanitarian science practiced on an international scale. Education was another cornerstone of the Institute's mission. Pasteur believed that the future of medicine and science depended on the training of new generations of researchers who shared his commitment to rigorous methodology and public health. The Institute offered advanced instruction in microbiology, immunology, and chemistry. Students came from around the world to study at the Institut Pasteur, bringing with them diverse perspectives and experiences that enriched the scientific community. Many of these students returned to their home countries to establish laboratories and public health programs, effectively spreading Pasteur's legacy across continents. Pasteur continued to work within the Institute until the final years of his life. Though his health had begun to decline, he remained a presence in its halls, consulting with researchers, reviewing findings, and offering guidance. The laboratory had become his sanctuary, and the young scientists he mentored became his extended intellectual family. In his final years, Pasteur often walked the corridors of the Institute, quietly observing the continuation of the work he had begun decades earlier. His satisfaction came not from honors or titles, but from knowing that the torch of discovery would be carried forward by those he had inspired. The impact of the Institut Pasteur on global health cannot be overstated. Over the decades, its researchers have been at the forefront of numerous breakthroughs, identifying viruses such as HIV, developing vaccines for diphtheria, tetanus, and yellow fever, and mapping bacterial genetics. The Institute has become a model for multidisciplinary collaboration and remains one of the world's most respected centers for infectious disease research. Its continued relevance in the 21st century speaks to the strength of the foundation that Pasteur laid more than a century ago. In essence, the Institut Pasteur is both a scientific institution and a monument to one man's unwavering belief in the power of knowledge to combat suffering. More than a physical structure, it embodies a philosophy, science guided by empathy, inquiry driven by purpose, and discovery dedicated to the service of all humanity. Through this institute, Pasteur achieved something extraordinary. He institutionalized his ideals, ensuring that his life's mission would live on through the work of countless others. The Institute stands not only as a beacon of scientific progress, but also as a living testament to the enduring influence of one of history's greatest minds. As the 19th century drew to a close, Louis Pasteur's influence extended far beyond the confines of his own laboratory and the borders of France. His name had become emblematic of a new era in science, one where methodical experimentation and human empathy could reshape the very foundations of medicine and biology. Though Pasteur passed away on September 28, 1895, his work continued to echo in every sterile surgical room, every vial of vaccine, and every scientific institution dedicated to the protection of human life. His legacy, meticulously built over decades of tireless labor, became a guiding light for future generations. The final years of Pasteur's life were marked by increasing frailty, a result of the stroke he had suffered years earlier and the physical toll of an intense and demanding career. Yet even as his body weakened, his intellect remained sharp, and his passion for inquiry never faded. Until his final days, he remained deeply engaged with the Institut Pasteur, guiding its development and mentoring those who would carry his mission forward. His death, mourned by the scientific community and the general public alike, was not merely the passing of a man, but the closing chapter of a scientific revolution. The state funeral held in Pasteur's honor reflected the profound impact he had on French society and the broader world. Attended by dignitaries, scientists, and citizens from many nations, the ceremony was both solemn and celebratory. Pasteur was laid to rest in a crypt beneath the Institut Pasteur, a fitting resting place for a man whose life had been so intimately entwined with that institution. The crypt itself was designed with mosaics that depicted his major achievements, each scene a tribute to his breakthroughs in microbiology, vaccination, and public health. In this space of reverence, visitors could not only honor the man, but also reflect on the transformative power of science. Pasteur's legacy soon transcended his direct contributions to microbiology and medicine. He had demonstrated the profound importance of applying rigorous scientific methods to practical problems, something that inspired entire fields of study to evolve in the decades that followed. In agriculture, food safety, public sanitation, and industrial processes, the Pasteurian approach became a gold standard. His techniques of microbial control informed everything from sterilization in hospitals to the fermentation processes in global industries, embedding his influence in the very fabric of modern society. Educational institutions around the world adopted his models of scientific training, emphasizing laboratory-based learning, critical observation, and ethical responsibility. His advocacy for public health measures contributed to the eventual emergence of epidemiology and preventive medicine as essential components of national healthcare systems. The principle that prevention was as crucial as cure, central to Pasteur's philosophy, reshaped public policy, especially in the early 20th century when diseases like tuberculosis and diphtheria still ravage populations. In addition to inspiring institutions and reforms, Pasteur's work ignited the imaginations of many of the 20th century's greatest scientific minds. Figures such as Alexander Fleming, who discovered penicillin, and Jonas Salk, the developer of the polio vaccine, often cited Pasteur as a major influence. His insistence that chance favors the prepared mind became a mantra for generations of researchers. His name became a symbol not just of microbiology, but of the courage to challenge orthodoxy and pursue truth in the face of skepticism and adversity. Pasteur's legacy also lives on through the international network of Pasteur Institutes, which continue to tackle infectious diseases around the globe. These institutes have played pivotal roles in combating pandemics, researching emerging pathogens, and providing crucial health care in underserved regions. Their very existence is a manifestation of Pasteur's dream of science in service of humanity, of a world where knowledge is shared and lives are saved through global cooperation and innovation. Beyond science, Pasteur's moral and philosophical contributions have resonated with scholars in ethics, philosophy, and history. His deeply humanistic view of science, as a moral endeavor committed to alleviating suffering, set a precedent for responsible scientific practice. He firmly believed that researchers carried a duty not only to discovery, but also to compassion. This view remains central to contemporary debates on the ethical boundaries of science and technology, and it serves as a reminder that true progress must always consider its impact on human lives. Statues, schools, streets, and even towns bearing Pasteur's name can now be found across continents, reflecting the widespread admiration he earned. Yet these physical memorials are secondary to the living legacy embodied in vaccines administered, diseases prevented, and lives improved through the knowledge he helped unlock. His story has been retold in countless biographies, films, and educational texts, ensuring that his contributions are remembered not just by scientists, but by students, patients, and communities around the world. Ultimately, Louis Pasteur's life and work represent more than a sequence of scientific milestones. They embody a vision of science as a tool of hope, resilience, and justice. He transformed not only how we understand the microscopic world, but also how we confront suffering, disease, and ignorance. Through his relentless pursuit of truth and his unwavering belief in the power of knowledge, Pasteur forged a legacy that continues to illuminate the path of progress. His enduring influence reminds us that, even in the face of uncertainty and adversity, one person's dedication can alter the course of history for the better.